We're now going to take a look at yet another synchronization primitive, and this primitive is called the barrier. So let's actually make one somewhere in our class, maybe not in the main function, but I'll have one here. So let's have static barrier, barrier equals new barrier. And let's discuss some of those constructor options. So what is barrier all about? Well, in some cases you can have multiple worker threads working on a particular algorithm, but they have to work in stages. Like all of the worker threads have to complete stage 1, and then all of the worker threads have to complete stage 2. Now let me give you an example of how that would work. Let's suppose we're still doing this setup of making tea. So let's separate things you have to do with the water and things you have to do with the cup and the tea and whatever. So I'll have static methods for both of these. So I'll have a static method for water, and we can assume this is going to be one of the worker threads. So here I'll write line, for example, that I'm putting the kettle on, and let's suppose that this will take a bit longer than some of the other operations. So somewhere here we'll have a thread.sleep for 2 seconds, for example. So while I'm making the water, while I'm preparing the water, I can also find a nice cup to pour the water in. So this can be done in a separate thread. Once again, public static void cup. In this case, I can write line the fact that I'm finding the nicest cup of tea, and this is a fast operation. It doesn't take, I'm not going to do a thread.sleep here. So essentially at this point I want to continue pouring the water, but I need the cup there. I want to maybe add tea and sugar, but I need the water in here. So I want to put a barrier that I can resume at this point and this point, and this is exactly what the barrier does. So essentially, coming back to the barrier itself, you can see that the barrier has the first argument is the participant count. In this case, the participant count is the number of worker threads that are going to be working on some algorithm. So I have 2 different threads. I have water and cup. Don't worry, I'll make tasks for them in just a moment. And then there is also the second argument, which is a handler for what happens when one of the phases is finished. And by phase, we mean this and this, for example. After this, there is the second phase where we maybe pour the water and add some tea or something to that effect. So here you don't really need to provide a handler, but let's provide one anyway. So in this case, the handler takes a barrier as an argument, and essentially all I'm going to do here is I'm going to write line the phase number that it's in. So the idea is that the whole process, however many threads you have, happens in phases, like phase 0, phase 1, phase 2. So I'm going to write phase and then b dot current phase number and specify that it is finished, so that we know the particular phase is finished. In addition to the phase, you can also get the other properties of the barrier. For example, you can get the total number of participants. In this case, we specify this as 2. You can specify the number of participants remaining. That means the number of participants who are yet to complete their part of work, because before the whole process starts again. There is also an ability to add and remove participants right in the process of using the barrier. So if you started out with 2 worker threads, but you realize you need a third worker thread, you can call add participant, or indeed add participants to add several of them. So that's also very convenient. Now let me show you how you would actually put the barrier at this location. So at this location, we want both of the threads to wait until they are both done. So to do this, you say barrier.signal and wait, and you do exactly the same thing here. Now let me show you the arguments. This is going to be a recurring theme throughout the synchronization primitives. You have arguments taking cancellation tokens, you have arguments taking the time span, timeout value, and you have arguments taking both the timeout and the cancellation token as well. So essentially both of these threads will execute. They will both reach this stage, and only after reaching the stage will they continue. Let's actually set up tasks for them. So I'm going to have var water equals task.factory.start new water, and I'll have var cup equals task.factory.start new cup, like so. And then of course I'm going to have the tea making process finished. I'm going to make tea and enjoy it when both of these are completed. So we're going to use that continue when all functionality. We're going to make a continuation dependent on both of these tasks, as we've seen in the previous lecture. So I'll say var t equals task.factory.continue when all. So I want both the water and the cup to be ready. I want everything nice. So here I provide an array of all the things I'm going to be waiting on. This is water and cup. And then I provide a lambda which takes all the tasks and which can do something with them. In here, I'm just going to write lines. So I'm going to say, for example, that I enjoy your cup of tea. That's it. And then I'm going to wait on this. So I'm going to wait on the final continuation. All right, now coming back to these water and cup workers, we have the barrier. After the barrier is passed, we can do the other part. So for example, here I can say that I'm pouring water into the cup. And here down below, I can say, for example, that I am I'm adding tea to the cup. Now, this is phase 1, so this and this is phase 0, this is phase 1, and then I can repeat the process. I can once again specify that I want to both signal and wait, and then I want to do something else. So here maybe I want to put the kettle away. So let's put this. So I'm putting the kettle away, and down here if I write line, maybe I'm adding sugar, for example. So we have set up an algorithm where we have a phase where the first thing from every worker thread happens, then they both signal and wait, then the second phase, then they both wait, and then the third phase. So if I execute this, you can see that first I'm finding the nicest cup of tea. There was a bit of a pause there because I put a thread.sleep for making the water. Then phase 0 is finished and we're into phase 1. And in phase 1, we pour the water into the cup in one thread and add the tea in another thread. And then that's phase 1 finished. And finally, we add the sugar. We put the kettle away, that's phase 2 finished, and then we get the continuation. So that's how you can define things using the barrier. Now I want to explain a bit about this signal and wait. There are two things happening here. One is signaling and the other is waiting. So the idea is that inside the barrier, just like in any synchronization primitive, you have some sort of counter. In this case, you have a counter which expects the count to reach the value of 2. So basically, as you get in here, the count gets raised. That's the signaling part. But then you're waiting and you're waiting on the signaling part to become 2. So let's suppose water is the first thread that actually reaches. Well, actually, it's the second because we put in the pause. So let's start here. We're going to reach this location first. Now, the counter is going to be signaled. So if it was originally 0, when we signal it, it's now at 1. But the barrier won't let us through because it wants us to have the value of exactly 2 before it reaches. So once we reach this point, the count increments again. It becomes a 2. And that's okay. That means that we can now execute. Until then, the waiting process happens. That's why it's called signal and wait. We increase the counter, but if it's not sufficient, if it's not as high as the value we have here, we're going to be stuck. We're going to be waiting here. So once signaling is done, once we reach the value, we continue and we execute the next part. However, as soon as we get to here, the count is reset. So at this point, the count is once again reset to 0. Now let's suppose we reach here. We signal and that increases the count from 0 to 1, but that's not enough because we need a 2. So we reach this point and we reach a 2, and that means that we are let through in both this location and this location, and we execute the final write lines, and that allows the continuation to continue.